Hello everyone, this is Rishu from Build2Scale. DynamoDB is a fully managed, highly available service with replication across multiple AZs. It is a NoSQL database and hence does not support joins and aggregate functions. It can automatically scale to massive workloads. DynamoDB service is very fast and consistent and it works on key value pair principle. It is fully integrated with IAM for security and authorization. It enables event-driven programming with DynamoDB streams and can handle millions of requests per second. Now let's talk about DynamoDB basics. DynamoDB is made of tables and each table has a primary key, which must be decided at the creation time. Each table can have a finite number of items, which is equivalent to rows in your SQL databases. Each item has attributes and can be added over time. Attribute values can also be null. We have one limitation on the DynamoDB that the maximum size of an item can be 400 KB. Let's have a look at the primary key for the DynamoDB. The primary key or the partition key must be unique and diverse so that data can be distributed on partitions. For example, in the employee table here, you can see two employees having the unique employee ID as 100 and 101. Using this unique identifier, we can easily search data in the DynamoDB. For composite hash and range key in DynamoDB, the combination must be unique for each item. Data is partitioned by the hash key and sorted by the range key. The default sorting is in ascending order. Let's have a look at the projects table here, which is having employee name as the hash key and project name as the range key. And the data here is sorted in the ascending orders by the project name, which is our range key. Now let's see what happens when we try to put an item or insert an item into DynamoDB table. We have an item here with the employee name as John and the project name as DynamoDB. Employee name here is a sort key. So based on the sort key, hash code will be calculated and based on the hash code, a partition would be decided and the item would be inserted in that particular partition. Now if we try to insert another item with employee name as Ram and project name as DynamoDB, hash code will be calculated based on the employee name and we will insert that item into a partition 2. Now if we try to insert another item with John and AWS Lambda, accordingly partition 1 would be decided based on the sort key, that is the employee name, and hence we can see John AWS Lambda is also inserted. The items in the partition 1 are inserted in the sorted order, that is based on the range. Now we try to get an item from the DynamoDB table with the employee name as John and the project name as DynamoDB. First, hash code would be selected based on the employee name and the partition would be partition 1. Now in partition 1, we have two entries, John AWS Lambda and John DynamoDB. To get the correct item, since the partition key is the same, DynamoDB hence would use the range key, that is the project name, to search in the partition and retrieve that particular item, that is John DynamoDB. Similarly, if we try to get Ram DynamoDB, first the hash code would be calculated based on the employee name, that is Ram, and hence the partition 2 would be selected. In the partition 2, we only have one item, so the data would be returned successfully, that is Ram DynamoDB. In case you want to create another sort key, you can do that using a local secondary index. It's an alternative sort key for a table and has the same partition key as the base table. Only 5 indexes are supported per table and must be defined at the table creation time. That's why the local secondary index should be chosen very carefully. We can also use attribute projections to project keys only, all, or include specific attributes from the base table. In case we want to search data by the non-key attributes, we can use DynamoDB global secondary index. 20 indexes are supported per table and they can be easily added and modified after table creation. Global secondary index speeds up query on the non-key attributes and also supports attribute projections. For event-driven programming, we can enable DynamoDB streams. Once streams are enabled, any insert, update, or delete on a DynamoDB item, a respective event would be put to the Amazon DynamoDB streams, which could be listened by various AWS services and act on it. For example, AWS Lambda can listen to the DynamoDB streams and maybe send it to S3 for capturing all the DynamoDB events. We have covered all the core concepts in DynamoDB. In the next video, I'll go through a detailed hands-on.